Okay, welcome to Valley Forge and Bolt. Want to talk about our Clarkster with a load indicating fastener. Basically what the Clarkster does for you, it turns bolt tension into a load reading on the bolt. Here's the bolt that you read. It's one of our load indicating fasteners. It's got a little cap that protects the top of it, and you have a meter that comes with the unit, and I'm going to go over nomenclatures and all how the part comes and cleaning of it and assembly and use, so that you know how to use the Clarkster bolt load monitoring system. Basically this clips on and reads bolt load in a % of the bolt's capability. So let's go over the mechanical side of the Clarkster unit. I'm going to put this bolt cap on first so it doesn't get damaged. Please keep the cap on the load indicator when not in use, or leave the reader connected to it. Basically the bolt is screwed into a plate. The plate is inside of the Clarkster in here. I'm going to show you how that works. You unscrew the bolt. It's a small little fastener, D7 bolt that we've made, and we've got a calibration chart that I will show you that goes with it. You clip it on, the protection cap, it's got a 1-inch washer, it goes underneath the head of it, and it screws back in. The plate inside has a round circular plate. Looks a lot like this one. That plate inside has 2 threaded studs that connect to it. So when the bolt is screwed in, the plate is back. Once the plate is back, you take your liner bolt, you put it in your testing pocket, then you slide this into the machine and put your nut on it. So I want to show you the whole assembly, but first I want to put it back together. Basically I've screwed back in the bolt into the back of the Clarkster, so now I cannot pull out on the studs. So they're located in there, and the system's ready to start testing a bolt. How do you test a bolt? You take the fastener that you want to test and you install it into a testing pocket. The testing pocket has a taper section like a liner bolt pocket, and then 2 holes on each side. This one is built for an 1.5-inch diameter liner bolt. We aren't going to test that one today. This one is built for a 2-inch liner bolt. There's the liner bolt pocket and the 2 alignment holes for the unit. We've got the bolt installed into the Clarkster. The cylinder is clean. It's lined up. I install my liner bolt through the test pocket, and then I slide the unit into the Clarkster. The liner bolt slid into the unit. You line up the side grooves, and so the pins align, the holes go top and bottom, and you slide it into the Clarkster unit. Once it's slid in place, you take the nuts to contain the pressure inside the fastener or into the bolt. These 2 studs connect the liner bolt to the larger fastener. We have a tool to install these nuts. You take it, screw them on. Make sure they screw on till they're just flush, but you don't have to tighten them. They just have to be flush. Once it's in, Your liner bolt is now installed, ready to put the front plate on. You don't need this tool anymore. You want to test the liner bolt 2, maybe 3 times and then change this liner bolt out. You don't want the liner bolt to gall or the threads to gall. You want to inspect it and make sure it's shiny. Make sure it looks like what you're installing on the mill. So if you're installing rusty bolts, use a rusty bolt. If you're installing a dry bolt with no lubrication, install a dry bolt. If they're lubing it, install the lubed one. You want to simulate what they are doing on the mill installation. This front pocket can be used for a 2-inch bolt or an 1.5-inch bolt. So for an 1.5-inch, we have a little insert that goes in there, and now it aligns for an 1.5-inch. For a 2-inch bolt, all you have to do is slide it on and align the keyways, and you're ready to install the liner bolt. With the sealing system, 2-piece sealing system, just like they're using on the mill, you make sure your rubber's in place. Slide it on the bolt. If they're using a lock nut, use a lock nut. If they're using a 2H nut, put that on. Install the liner bolt. You got your sealing washer, you got your nut that you're using, and the liner bolt ready to test. The SPC 404 meter, you turn it on and it'll go through its programming setup. It reads dash 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 when it's not connected to anything. Within the kit, we've supplied a calibration tester that says one side says 100, one side says 0. So you clip on and you can see this says 101. That's the 100% side. And here it reads 1. So plus or minus 5%, you're going to see bolt loading. Basically, there's an adjustment if this gets out of calibration that we can go over at a later date if you find that your unit gets out of calibration. But right now we're focused on the Clarkester testing. This unit would be considered in tolerance. You put your unit right there, you take your tester off, put it back into the plate or into the kit, take the cap off the back of the load indicating fastener and clip on. Currently this is reading 0 bolt load. So you get your SPC 404 meter, you clip it onto the fastener and you read load, okay? Plus or minus 5%. This one's currently reading 2. That would be determined in calibration. You make sure then you get your torque wrench or whatever tool you're using to tighten your liner bolt, impact guns or whatever, and you want to take this to load for the fastener application on the mill, okay? This table is designed to take a reaction arm built within the unit. It can react against this plate without destroying the unit. The Clarkester unit is totally self-contained. So if I was going to take a torque multiplier, a RAD 85, an air torque multiplier, a hydraulic torque wrench, I could put it right onto the face and let it react into the table. If an older style air torque multiplier takes air input off of some type of regulator, a sun gear assembly, and a reaction arm point. This would be able to do the job. I would put air to it, pull the trigger, it would react against the cable and tighten the nut up, okay? So loosen, react off the table is totally acceptable. Clarkster unit should look like this, basically set up in the field. Test your bolts 3 times, inspect the threads, make sure you don't have any galling or whatever. Make sure then you can use the bolt again with the same installation characteristics as you would if it was going to be a new fastener as used on the mill. Basically, the meter is going to read as you increase load. It's going to pull on the liner bolt, it's going to pull on those 2 pins and react to force in the load indicating fastener in the rear. reading on the meter. The force that the bolts apply don't change that much, but when we find mining bolts out in the field, we usually find them installed to about 50,000 pounds of load. What does that mean on the Clarkster tester? Basically, you look at your paperwork on the Clarkster itself, and you will come with instructions, operating procedures for the Clarkster load tension load cell, okay? It'll come with a serial number for this gauge. If you have an ISO program and you need to get this recertified, what does this tell you? It tells you how accurate your gauge is, your 404 meter. Is it reading 0? Is it reading 100? How does it work? Zero load on the back fastener, the zero side is flush, okay? And as the load gets installed on the liner bolt, pulling on the load indicating fastener, it pulls the shank down and the pin down, and the head is stretched out. So the difference is the center pin, and you can feel it on the 100 side, the pin is 5 thousandths below the top surface that we measure. And since strain is linear, we can see 0 to 5 thou, we can see the force within that change in measurement. So when it's at 2 thou or 3 thou, we measure it out on the meter. So 100% is 5 thousandths extension, 2 thousandths, it's going to be read on the meter appropriately. How do you tell that? When it's at 27%, you look at the chart that comes with the meter, okay? Basically, you go across here and say, I'm using a grade 5 liner bolt, 100,000 pounds of load, 120,000 pounds of load. This is 150,000, and you come across here to the chart, and you say, okay, I want to read 100,000 pounds of load. I'm looking around 35 to 37% load on this meter. And that equates to load here, and percent is here. So, in reading my fastener, if I'm at 50%, my load on my bolt is 150,000 pounds of load. Can that bolt handle it? Can a grade 5 liner bolt handle it? Yes, it can. A 2-inch grade 5 can go into the 200,000 range, but it might yield in static loading of the, or not static, but operational loading of the mills when you put in extra forces on it. So we want to give you a bolt that clamps the liner down with 100,000 pounds of force per bolt and gives you room for loosening and also gives you room for operational forces within the mill. So 100,000, 120,000 pounds of load. Basically on the meter you want to read between 35 to 39% on this meter. That's it for the SPC 404 meter connected to the Clarkster unit. If you have any questions, we'll be glad to help you anytime. You got my mobile phone, you got the internet, you can catch us either way. So appreciate your time.